everyone, in this video I will explain the topic of differentiation of basic functions. For your information, there are four basic functions. The first one is polynomials function. What is polynomial function? Polynomial function is a function that contains x to the power of n. You also can use y or any other letter to the power of n. So, for example of polynomial function are x to the power of 2, x to the power of negative 3, negative 2, x to the power of 5, 1 over x to the power of 4, and etc. Second function is exponential function. Example of exponential function are exponent x, exponent negative 2x, 2 exponent 3x, and etc. The third function is logarithmic function. Example of logarithmic functions are log x, log 2x, 2 log 3x, and etc. And the last function is trigonometric function. Example of trigonometric function such as sine 2x, cos 5x, tangent x, and etc. Now, let us define what is differentiation. In the simplest words, differentiation can be defined as the rate of change of the function output, commonly denoted as y, with respect to its input, commonly denoted as x. Notation that can be used to represent differentiation is d over dx. You use this notation whenever your function is given in the form of expression. For example, x to the power of 2. So, in order to find the differentiation of x to the power of 2, you will write d over dx, x to the power of 2. Okay. Next notation that is quite common used to represent differentiation is dy dx or y prime x. This notation is used whenever your function is given in the form of y equal to exponent x, for example. So, in order to find the rate of change of this function y, which is the output function, with respect to the inputs x, you will write dy dx is equal to this function. Or y prime x is equal to d over dx of the exponent x. Next, we also use f prime x whenever the function is given in the form of fx is equal to ln x, for example. So when you want to find the derivative of this function, you write f prime x. And the last one is capital D x. This is also quite common as the notation for differentiation. Now, let's go to the first differentiation for polynomials function. The rules to differentiate polynomial function start with d of dx for a constant denoted as a is equal to 0. So whenever you differentiate a constant, you will get 0. For example, you have function y, which is equal to 3. As we know, differentiating function output y with respect to x means that your right hand side term must contain x. But in this case, you have no x on your right hand side. So when you differentiate your function y here with respect to x that should be on the right hand side here, okay, is equal to 0. There's no x on the right hand side. So whenever you differentiate with respect to x, you get 0. So this is correct all the time whenever you differentiate a function that is equal to constant. Next rules. You differentiate a function x with the power of 1. You will always get constant 1, which is equivalent to 1. Whenever you differentiate only x, you will get 1. For example, you have y equal to x. This means your x is having power 1. The rules of differentiation is the power you multiply to the front of your variable x. So you will get dy dx because you're differentiating y with respect to x on the right hand side here, and your x here is having power 1. So 1, the power 1, you multiply to the front, you will get 1. And then you write your x, but for the power, you must reduce 1 first before you write it to your x. So this will give you 0. We know that any variables that is power 0 is equivalent to 1, right? X to the power of 0 is equivalent to 1. So that is why when you differentiate only x, you will get 1. Because 1 times 1 will give you 1. Okay? Now, let us look at another example. whenever you have y is equivalent to 2x. Now, still here, your x is having power 1. 2x power 1. So when you want to find the dy dx, what happened is 1. You multiply to the front here. So your dy dx is equivalent to 1 multiply with your 2x here. But before you write any power to your x, you must reduce the power by 1. That will give you 0. Okay, so here this is equivalent to 1 times 2 times 1. So the answer is 2. There's a correction here. I should put a bracket to the 2 here and create another bracket for x then. Okay, next rules. When you differentiate a function x to any power n, where n is 2, 3, and so on, so you will get the answer n at n minus 1. This is the rules. When you differentiate x to the power of n, where your n is 2 and above, right, you will get the answer and multiply with your x, while the power will reduce 1. Example, you have y is equal to x to the power of 3. So x here having power 3, right? So 3 multiply to the front. So dy dx is equal to 3. Write your x here. And then before you write the power for x, you must reduce it by 1. That will give you 2 here. Okay. Next example, y is equal to minus 2x to the power of 4. Finding the derivative for this function will give you dy dx is equal to 4 multiply to the front here. That will give you 4. And then minus 2 x. Before you write the power for x, make sure you reduce it by 1. That will left you with 3. Simplify this, you will get negative 8x to the power of 3. Next example, y is equal to 3x minus 3. Finding the derivative for this function, you will get dy dx is equal to, always start with the power multiply to the front here. So minus 3. We write again 3x. Before you write the power for your x, reduce it by 1. Then you will get negative 4. Simplify this, you will get negative 9x to the power of negative 4. Last example, let's say you have y is equal to 1 over x2. Okay, to differentiate this function, it is recommended to you to rewrite this fraction into the simplest x to the power of n, which is equivalent to x to the power of negative 2. Okay, only then it will be easier for you to differentiate the function dy dx is equal to power multiplied to the front minus 2 x reduce the power by 1, that will give you minus 3. Or also you can rewrite this to minus 2 over x to the power of 3. It's easy, right?